Hi everyone, and welcome to the MAT 211 review of probability density functions. My name is Julia, and I work for the tutoring centers at ASU. So, the gas prices in a region were normally distributed with a mean of $3.01 and a standard deviation of $0.36 or 36 cents. A particular gas station charges $3.92. What percent of gas stations in the region charge more than this gas station? So we know that our mean, mu, is equal to 3.01. We know that our standard deviation, sigma, is equal to 0.36. And we're looking for the probability that x is greater than this value 3.92, where x in this case is the price of gas at some randomly observed gas station. So let's think about what this means in terms of a normal distribution here, since we know that the gas prices are normally distributed. So if we draw kind of a badly shaped bell curve here, we know that our mean, which is going to be right at the top here, or would be if I could draw a normal distribution correctly, we know that that mean is going to be 3.01, right? Now, this threshold number that we have, 3.92, is going to be somewhere up here, because remember that larger values are going to be that is, values larger than the mean are going to be to the right, whereas values smaller than the mean are going to be to the left. So we have 3.92 somewhere up here. We don't know exactly where yet, but we'll figure that out. So the first thing we can do is figure out what our threshold $3.92 looks like as a z-score. So remember that a z-score is going to be calculated as x minus the mean, mu, divided by the standard deviation, sigma, which in our case is 3.92, that's this x value here, minus our mean, mu, which is 3.01, divided by our standard deviation, which is 0.36. And if we throw this into our calculator, we find that it's approximately equal to 2.53. Now, there are a lot more decimals here, but I rounded this to 2 decimals because I happen to know that my z-table only goes up to 2 decimal points, as do a lot of them. So this means that our probability here that x is greater than 3.92 is equal to the probability that z is greater than our 2.39 here, or 2.53, excuse me. So let's write that a little bit more neatly over to the side here. Get rid of that. So we've got this is equal to probability that z is greater than 2.53. There we go. So we need to figure out what this probability is. Now, we're looking for this range in here, so we're looking for the probability or the area under the curve that corresponds to the range that's larger than our 3.92. So if we think of this in terms of a z-score, if we replace these values with their z-score components, so this is our z, this would be 2.53, and our mean is 0 now, because remember when we switch to the standard normal distribution, or the z distribution, our mean is 0. So we could find this value with a calculator. I'm not going to go into that here simply because all calculators are different and it's kind of hard to project a calculator on the screen. But if you're looking for how to do this on your calculator, my suggestion is that you type the model and make and model of your calculator. So for instance, I have a TI 84 Plus. Type that, as well as, you know, find a normal probability, or find z probability, or find z-score, something along those lines, into Google, and it should come up with all sorts of videos, like YouTube videos and like help documents that'll show you how to get your particular calculator to find these probabilities that correspond to our z-scores. But we're going to go ahead and do this with the z-table here. So to the right, I have part of my z-table. Notice that I subset it to just the values around my z-score here, just so it would fit on the screen. And also notice that it is a left-handed z-table. That is, the areas are calculated to the left of wherever your target z value is. Now, notice when we did our drawing, we're looking for everything larger than our z-score here. So any probability that corresponds on this table is actually going to be this range right here, all the way down through the left tail here. So how do we go ahead that fact to figure out what we need to do to calculate our probability? So if we look at this, we know that this range here to the left plus the range that we're looking for to the right of our z-score has to equal 1. So therefore, if we subtract this range from the left from 1, we'll get the range that we're looking for. So that looks like, this is the probability of 1 minus the probability that z is less than 2.53. So let's look on our table. So these are all going to be probabilities that z is less than something, whatever our probability, our probability that z is less than something. So in our case, 2.53. So we'll first start on the columns. We find 2.5 here. And then we're going to look in the rows well, I guess these are the rows and these are the columns. But we have 0.3 here. So 2.5 plus 0.03 is equal to our 2.53 that we're looking for. So if we just follow along here and we follow along here, we get to the value that we're looking for. So remember, this value here, which is equal to 0.9943, is equal to the area to the left of our z-score. So everything in pink here. So we can substitute this into our equation here. So because this value here is equal to the probability that z is less than 2.53. So we have 1 minus our 0.9943 that we found from our table, and that equals 0.0057. So that's the probability that z is less than 2.53, which is equal to the probability that that's the probability that z is greater than 2.53, which is equal to the probability that x is greater than 3.92, which is what we were looking for. However, note that we're looking for the percent of gas stations, not the probability of gas stations or the proportion of gas stations, because those are the same thing. But we're looking for the percent, so we need to convert this proportion here, or probability, to a percent. That means we just multiply it by 100 and put our percent sign in front of it. So that's going to be equal to 0.57%. And that's our answer. So what this tells us is that 0.57% of gas stations in the region charge more than this gas station that charges $3.92. So not very many. Sounds like this particular gas station is one of the pricier ones in the region. So that's it. We're all done. Oh, and last thing to note before I go is that we were calculating this with a left-handed probability. If we had a table that had a right-handed probability, so instead of this drawing here, we had something that looked like this, where we were getting everything to the right of our z-score, then we wouldn't have to go through this 1 minus. We would just, that would be our value for z. It would correspond to this number here. But since we have it looking the other direction, we have to do this 1 minus to get the probability that we're looking for. So great, all done. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring for your specific course, you can use our tutor search tool, which you can find on our main website page here, or by going directly to the tutor search tool at this full link on the screen. So thanks so much, and have a great rest of your day.